Hi everyone, I am Muthuramji, Assistant Professor in the Department of EEE, Hindustan College of Engineering Technology, Coimbatore. So in this video, we are going to see the important topic in the three-phase induction motor. So in a three-phase induction motor, the very important topic is how to start that three-phase induction motor by using an appropriate starters. Because in this three-phase induction motor, there are two types are there. In according to the rotor configurations, we are having cage rotor and the wound rotor. So there are three-phase squirrel cage induction motor and three-phase slip ring induction motors are the two types of motors. So this is the stator frame and this is about the stator core. So this stator core which is placed inside that stator frame. So on the top of the three-phase induction motor, a terminal box which is located, and in the terminal box we are having 6 terminals. So that 6 terminals are connected either in the star or delta according to the images. So here W2, U2 and V2 are interconnected on the top, and the U1, V1, W1 are connected with the respective phases R, Y, B. And in the case of delta connected, we can short the W2, U1, U2, V1 and V2, W1, and any three terminals, that is U1, V1, W1 are connected with the respective phases. And next one, the configuration of the rotor. I already mentioned that there are two types in the rotor configuration. One is called cage rotor, another one is called as wound rotor. So that cage rotor which will give you the low starting torque, and the wound rotor which will give you the high starting torque. So in the wound rotor, there are another two components are added here, brushes and slip rings. And the rotor circuit is extended to the variable resistance through that slip rings and brushes. And this is the images of the rotor stampings, and this outer part of that stampings are called as teeth, and the slot positions which are used to accommodate the windings. And we are coming back to that topic. So what is the necessity of the starters? So in a three-phase induction motor, the magnitude of an induced EMF in the rotor circuit, which will depends upon the slip of the induction motor. You know that slip is ns minus nr divided by ns into 100. That percentage may be less than 5%. And this induced EMF effectively decides the magnitude of the rotor current. So the rotor current can be determined by that formula I2R is equal to S into E2 divided by root of R2 squared plus SX2 whole squared. So I2R is nothing but a rotor current at running condition, that is equal to slip times of induced EMF on the rotor side, and it is divided by the rotor resistance squared plus slip times of rotor reactance whole squared. So from the expression, you can notice that the rotor current can be seen that it can be controlled by reducing the E2. That means whenever you are going to reduce the induced time on the rotor side. So I2 is directly proportional to E2 from the above expressions. So it is possible by two methods. The first method, you can supply the reduced voltage at the time of starting, or by increasing the rotor resistance R2 at the time of starting. The first method is called as stator side control. The second method, of course, it is called as rotor side control. So this second method is possible only in the case of slip ring induction motor. And you can see what are the types of starters. So let us start with that: stator resistance starter, direct online starter, star delta starter, auto transformer starter, and rotor resistance starters. So we can start with that first one. It's a very simple circuit. The stator circuit has three variable resistance. So in order to apply the reduced voltage to the stator of the induction motor, three resistance are added in the series with each phase of the stator winding. Initially, the positions of the resistance are in maximum. Due to this, a large voltage gets dropped across the resistance. Therefore, we can reduce the voltage in the stator side, which will reduce the high starting current. And when the motor starts running, the resistance are gradually cut off from the stator circuit. Therefore, the resistance are entirely removed from the stator circuit. That means the rheostat are in the run position, then rated voltage gets applied to the stator. Now the motor runs at the normal speed. And the stator resistance starter, it's a very simple in construction, and also it is available in cheap. And another important advantage of this starter is we can use it for both star and delta connected in the stator, but it gives an huge power loss because of the three individual resistors are connected in the stator circuit. Also, the starting torque of the motor reduces due to the connections of the resistance. So we can move to the next starter called direct online starter. So the direct online starter, you can see the diagram. Three-phase supply is connected to the stator of a three-phase induction motor through that contactors. So in the case of contactors, you can see this is called as main contactors, and this one is called auxiliary contactor. So this contactor, you can see this one is the auxiliary contact, and this is called as the magnetizing coil. Okay, and you can see that R phase is directly connected to the contactor directly, and in the case of B phase and Y phase, Y and B, these three are connected to the circuit. So that one of the terminal, that means if I can take that B is connected through the NO. NO means normally open and NC is normally closed. So whenever I am going to press this normally open, whenever I am going to press that normally open, then only the current will flows through the magnetizing coil. Whenever the magnetizing coil is excited, it will attract the contactor. Therefore, whenever it is attracted, that three lines are energized. So the stator gets a supply. Okay. And now the motor will start to run. Suppose if I am going to switch off that motor, I am pressing this NC. So that normally closed, now it comes to normally open. Therefore, the magnetizing coil gets de-energized, the contactors are released. Therefore, the stator has no current. Therefore, the motor comes to off. Okay. So this is the direct online starter. So in case of a small capacity motors having the ratings are less than 5 HP, the starting current is not very high, and such motors can withstand such a starting current without any starters. There is no need to reduce the applied voltage also. Okay. And in the case of direct online starters, it is used to connect stator directly to the supply lines without any reduction in voltage. Hence, this starter is known as direct online starter. Though this starter does not reduce the applied voltage, it is used because it protects the motor from various severe abnormal conditions like overloading, low voltage, single phasing, etc. And this direct online starter, normally open contact is connected in the supply between the any two of the lanes, and NC, of course, it is connected in the magnetizing coil. So at the time of starting, NO is pushed for fraction of second due to which coil gets energized and attracts the contactor. So stator directly gets supply. The additional contact provided ensures that as long as supply is on, the coil gets supply and keeps contactor on positions. When NC is pressed, the coil circuit gets opened, due to which coil gets de-energized and the motor gets switched off from the supply. Under overload condition, current drawn by the motor increases, due to which there is an excessive heat produced, which increases the temperature beyond the limit. Thermal overlays get opened due to high temperature, and it will protect that motor also. The next type is called star delta starter. You can see the diagrams. There are three phase lines which is connected to the stator windings. You can see this is the stator winding. So the three phase supply is connected across three phase windings, and this is the DPDT switch, triple pole double throw switch. Okay, so this is the cheapest starter, and it is very commonly used in all induction motors. So the triple pole double throw switch is also connected. This switch connects the stator windings in star at the time of starting. Therefore, the per phase voltage we can reduce by the factor of 1 by root 3. Due to this reduced voltage, the starting current is limited. So when the switch is thrown on the other side, the winding gets connected in delta across the supply. So it gets normal rated voltage. The windings are connected in delta when motor gathers sufficient speed. So the operation of the switch can be automatic by using relays, which ensures the motor will not start with the switch in the run positions. And the star delta starter, which is the cheapest starters and also the maintenance free operations also having. But only one limitation is the normal delta connected motors, it is suitable, and the factor by which voltage changes is 1 by root 3, which cannot be changed. The next one is called the auto transformer starters. It is mostly used on the industrial side, and a three-phase star connected auto transformer can be used to reduce the voltage at the time of starting. It consists of a suitable changeover switch. When the switch is in the start position, the stator winding is supplied with the reduced voltage, and this can be controlled by limiting that starting current. The reduction in applied voltage by the fraction percentage tapping X used an auto transformer, which is shown in above. So when the motor gathers 80% of its rated speed, the changeover switch is thrown into run position. Due to this, rated voltage gets applied to the stator winding. Now the motor starts rotating with the normal speed. Changing of switch is done by automatically by using the relays. The power loss is much less in this type of starting. It can be used for both star and delta connected motors, but it is a costlier one rather than the other starters. And this is the last starter, which is specifically designed for the slip ring induction motor. So to limit the rotor current, which consequently reduces the current drawn by the motor from the supply, the resistance can be inserted in the rotor circuit at the time of starting. So this addition of the resistance in the rotor circuit is in the form of three-phase star connected rheostat. And the external resistance is inserted in each phase of the rotor winding through the slip rings and brush assembly. Initially, maximum resistance is in the circuit. As the motor gathers the rated speed, the resistance is gradually cut off. These operations may be manual or in automatic. So starting torque is directly proportional to the rotor resistance. So advantage of this method is not only the starting current is limited, but also starting torque of the motor also gets improved. But the limitation of the starter is it can be used only for slip ring induction motor. Now you can see the comparison of the stator resistance, auto transformer starter, star delta, rotor resistance, and the direct online starters. So with the variance of advantages, the star delta is useful for less than 5 HP motor, and the direct online starter is very suitable for less than 3 HP, and it's a fractional HP motors, and the auto transformer it can suitable for high HP ratings. And in the case of rotor resistance starter, mostly it is useful for the slip ring induction. It's a dedicated starter also. It will be useful for only the rotor resistance starter, which is suitable for only slip ring induction motors. Thank you.